Have you ever wondered how we can see right inside our own bodies without making a single cut? Well, the answer lies in this powerful, invisible kind of light that's born from a pretty incredible process. So today, we're going to dive into the surprising story and the just fascinating physics behind how X-rays are actually made.
Now, this story doesn't kick off in some high-tech modern lab with a clear objective. Nope, we've got to go back to the late 19th century to a moment of pure chance and a mysterious glow in a dark room.
Okay, so picture this. The date is November 8th, 1895. A physicist is working late in his lab with something called a cathode ray tube. Suddenly, he notices a weird glow on a fluorescent screen nearby. Now, what's so strange about that? Well, the tube was completely covered in thick black cardboard. Something invisible had to be passing straight through it to make that screen light up.
And that physicist? His name was Wilhelm Röntgen. And honestly, he was baffled. He had absolutely no idea what these powerful, unseen rays were. So he gave them a name that just perfectly captured the mystery. X-rays. The X literally for unknown. It's such a simple name for a discovery that would, no exaggeration, change our entire world.
This quote really says it all, doesn't it? A new window into the unseen world. You know, shortly after his discovery, Röntgen created the world's very first X-ray image. It was this hauntingly beautiful picture of the bones in his wife's hand, and you could clearly see her wedding ring. I mean, think about that. For the first time in human history, we could see inside a living person. The unseen world was suddenly right there on display.
All right, so how do we get from that first little glowing screen to the massive, powerful machines we have in hospitals today? Well, the magic happens inside this specialized vacuum chamber called an X-ray tube. So let's, pop the hood and see how it works. Everything starts with the cathode. Think of it like the starting line in a drag race. It's got this tiny tungsten filament inside, and when it gets heated up, really hot, it starts to boil off electrons. It creates this super energized cloud of them, just boiling for the green light.
So where are all those electrons racing towards? They're headed for the anode. This is the target. It's a positively charged block of metal, usually tungsten, which is perfect because it can handle insane heat. The anode's one and only job? To stop those speeding electrons dead in their tracks. Okay, we've got our electron source, the cathode, and our target, the anode. Now for the main event. Let's walk through the incredibly energetic, violent process that actually forges these invisible rays. It all happens in this four-step blast, right? First, emission. The hot cathode releases that cloud of electrons. Then, acceleration. A massive voltage, we're talking tens of thousands of volts, slingshots them across the tube at a huge fraction of the speed of light. Third, deceleration. They slam into the anode and stop, just almost instantly. And finally, conversion. That sudden, violent stop converts all their motion energy into powerful radiation. But here is the part of this whole thing that just blows my mind. The entire process is incredibly inefficient. Of all the electrical energy we pump into this system, less than 1% of it actually becomes the X-rays we want. Less than 1%. So you're probably asking, what happens to the other 99+% of that energy? Well, it just explodes as pure heat, a massive amount of it. And this creates a huge engineering challenge. It's the reason X-ray tubes need these really serious cooling systems, often with circulating oil or even spinning anodes, just to keep the whole target from literally melting into a puddle. But the story's not quite over. That tiny fraction of energy that does become X-rays, well, it isn't just one thing. It's actually being created in two fundamentally different ways at the exact same time. So these two types are called Bremsstrahlung and characteristic radiation. Bremsstrahlung, which is German for braking radiation, it's kind of like a comet swinging past the sun. An electron flies super close to an atom's nucleus, gets its path bent, and slows down. And that energy it loses is shot out as an X-ray. This is how most of the X-rays are made. Now, characteristic radiation is more like a game of cosmic billiards. An incoming electron scores a direct hit, knocking out one of the target atom's own electrons. Then when another electron drops down to fill that empty spot, bam, it releases a very specific, predictable amount of energy as an X-ray. So to put it another way, Bremsstrahlung gives us the smooth rainbow of all different X-ray energies, a continuous spectrum. But characteristic radiation adds these sharp, specific spikes of energy on top of that rainbow.
And what's really cool is that these spikes are like an atomic fingerprint. They are unique to whatever material the target is made of, so in this case, tungsten.
All right, so after all that crazy physics, we have finally forged these invisible rays. So, why do we care? What makes them so special and so unbelievably useful? Well, X-rays have a few unique superpowers. They can pass right through things that block normal light, and they travel in perfectly straight lines. But the real secret sauce, especially for medicine, is this property called differential attenuation. It's a fancy term, but it means something really simple. Dense stuff, like bone, is way better at stopping or absorbing X-rays than less dense stuff, like your muscles and soft tissues. And that difference, the shadow that your bones cast on the detector behind you, that is exactly what creates the image we see.
So there you have it. We've gone from a chance observation of a glowing screen all the way to a technology that creates invisible light by slamming electrons into a metal target. It's a technology that gave us a window into our own bodies, into the very structure of materials, and even helps us understand the stars. And it all started because someone noticed something that just shouldn't be there. It really makes you wonder, doesn't it? What other invisible forces are out there just waiting for the next accidental discovery?